Today, our class is about data scientists. What the role to become data scientist? What is your duty, your task? As a company, do we have different rules? Let's see. So let's say if I'm asking a question and using data to find the answer, I am a data scientist or no? The point here to have the good question that you asked to get the real information that we needed in analytical. So maybe, yeah, to give the correct question and to have the correct data from the person, we are data scientists. The idea here, sometimes when we go to collect data from the stakeholders or the customer, they didn't know what they want. And the idea here, sometimes they hide information which is much more important. Maybe unintentionally, they hide this information, or they hide it because they scare if someone take their position, or yeah, there is many scenario can have it here. So my duty as data scientist to ask the correct question that lead me to the correct data that I needed to help to have decision. So today we need to describe who is data scientist as professional, explain the path, the pillar to become data scientist, discuss the 12 tasks of data scientist, summarize some skills and training for data scientists, and to how to become a data scientist. Here there is a video for this person. You can have it, who is really data scientist. So you need to have it. Is data scientist one of the really hot topic in this era? Yes. Still, until now, we have lack of data scientists. This statistics for 2020, they say it's still 2020. We need 20,000 data scientists, but still until now we need and we have this gap. So still one of the hot topic, and the idea that they are one of the professional people that their salary is high. Also, Malaysia still need those data scientists and expert in data science. As we see, still data scientist one of the most higher job that they have, and have um, high salary. Until this era and this year, the same position, the second or the third position. This statistics is for America, but still for the whole world, the same topic, top 5 job we can find it. Okay, let's see. Here we have math, statistics, substance synthesis experts, computational and data skills. We see here that as a data science, you should know all these skills that help me to become data scientist. So I should understand what mathematics and equation I should use, and algorithm, and why this is the correct. Also, we need some computational and programming skills that help me to use software or to build some modeling. We need to know some experts skills that also help. So as a primary experts, we should know how to decide what conclusion down from analysis to be generalized, We should know how we set up the server, this data streaming in real time, especially when we have a large data. We need to know what data we should gather, what data we should collect it, because previously we say that sometimes we collect data, but it's waste data. It's not the correct data we needed. When I start now, I said that when we ask the correct information, that means I can have the correct data. It's not about collecting data, it's about collecting the correct data. We need also to automate and measure multiple data set, how we can deal with this multiple source of data set, detect the signal with the noise. Sometimes we collect, well, not sometimes, usually when we collect data, we have noise in this data. We need to do pre-processing for this data. What's the pre-processing, the correct pre-processing that we needed? We need to reduce the number of variables that need to be considered as a particular analysis. Not all variable is useful for this study or this study, so we need to use the correct variables. Sorry. And we know also we need to have management system that help in managing all these tasks. So some of this part is data science. At least if it's not my task in a company, I need to understand how I can do it. So here at Venn diagram, we have data science, we have mathematics and statistics, machine learning, unicorn, traditional software, traditional research, subject matter experts, computer science. So we need to understand at least the basics of these aspects. Because why we have matter experts, subject matter experts? Because okay, I'm data science, I'm dealing with data, but this data for which field I need it? I need it for medical, I need it for public diplomacy, I need it for communication, advertising, commercial. So we need to understand where to use this, for what major we need to use it. We need to understand the math and statistics, especially as we know that many of the algorithm in computer science based on mathematics. So we need to understand. Also, when we go for analysis data, there is different kind of algorithm we have, but every algorithm have its own work. Like in machine learning, some of this algorithm, the data set is images. We cannot have text data set. Some of this algorithm, the data set should be text only. Even that, the algorithm will not correctly work. So we need to understand this basics of the algorithm we have. Here at keynote speaker talking about data science is just machine learning, is just statisticals. So here we need to understand, is data science only machine learning or only statistics? No, it's combined between different aspects as we see here. So data science is using data to answer questions, which is the correct question we need to ask. So the ability to take data, to be able to understand it, to process it, to extract value from this data, to visualize, to communicate, this is going to be a hugely important skills in the next decade. This is what we need. Data science is the science of analyzing raw data, using statistics, using machine learning, using different technique, algorithm in computer science. At the end, we need to conclude this data and draw information from the raw data. So I need to visualize the inside of this data and convert it to information that we use it for other experts. So here, let's see what data science from different perspectives. For my boss or the boss of the company or the stakeholders, data science is money. How we can have money from data science. For the customer, he need to know answers. So the customer should give answers or have answer for his questions. What software engineering see data science is like a box from statistics, mathematics, and machine learning and give answers. What data science from the data scientist's perspective? Statistics, software, data source, infrastructure, algorithm, computer science. So here, our perspective as data scientist. So here, the correct perspectives from the data science science view. So here, our goal isn't to accumulate answer, but to ask better question. So as I said previously, my goal to ask the correct question that give me the correct data I need. It's not about just collecting data. So here our goal to ask better question. If you are asking question and using data to find answer, you are a data scientist. So we have a good generalist and good specialist. Good generalist, familiar with every part of data scientist, recognize all aspects, technical analysis, implementation, statistics, machine learning, computer science aspects from data science aspects, modeling, results, who is general, still general. But good specialists understand one area deeply, explain their area as expert to non-expert, understand the trade-off between different approaches. Why? As example, let's go for the algorithm that we use it as data scientists. We have much kind of algorithm. Every algorithm have its own way, and why this algorithm, not this algorithm here, the expert or the specialist should be have his justification why this algorithm, no, not this algorithm. And the idea here that his task or duty to give me high quality result, which will be more quality result, high quality result than the generalist. The reason data science feels so big is because it is no longer a single field. So data scientist is multidisciplinary field. We can go for three pillars: data analyst, data modeling, data engineering. So data analyst is the person who turning raw information into knowledge that can be acted on or can be acting on. Data modeling use data we have to estimate the data we wish we had. So data modeling to transfer the data we have to data we wish we have, like prediction. Data engineering, making everything work fast, more robustity, and great skills. Who is data engineering? So we have here three aspects or three different disciplinary for data scientists. So the general person or data science, the general data science should be know all these tasks. But for specialist, he will be special in one area. Let's see. So data analysis are several aspects of data analysis, the process of taking data and turning this data in information that we can use to make a decision. So we have domain knowledge, translate a business need to a question. So here, the data analyst task to ask the correct question, to convert the business need and requirement from the stakeholder to correct the question that lead us to collect the correct information. So here, the correct of answer that we have it depend on the correct question that we ask and depend on the business requirement and need which come from the stakeholder. So also we need to know how much time and money we need to spend to find the accuracy cost trade-off or the correct answer that we need. Money because we know that we have limited budget. Time because no need for data if the time is go on. Let's say I need to open a shop for or I need to produce a clothes for summer. But I finish my analysis after autumn. So we will start now on winter uh, season. So no need for the summer clothes in the winter season. This is why we should take care from time. Research, we need to translating information into action, gather the data, design, and conduct experience. It's not only about collecting data, is how to gather this data and design it and conduct the experience so it's become like research. Interpretation, give a large collection of data we can summarize, visualize this data into picture so it will become easy to have the result, understand the result, and apply statistical tool for statistical summarize. Like we need flow charts, we need visualization, so it's easy to understand what we have for result. In data modeling, we have three types. So data modeling have several major subcategories in machine learning as example, creating simple description to our data. We can make estimate for the data that you have not measured. For example, we have supervised learning data. We have unsupervised learning data. We have customized algorithm. Okay, what's the difference between supervised learning and unsupervised learning? Let's say that our data is for patients who have cancer and people didn't have cancer. If I label the data with cancer and non-cancer, so I collect the data for patients who have cancer and I label this data cancer and another folder for the people who didn't have cancer and I label it people didn't have cancer. So I put label, I put guideline for the machine learning. So we call supervise because I supervise the model to understand that there are two category of data we have. One, which is cancer, people with cancer. One, then the second one folder, or the second folder, which is non-cancer. So here I supervise and I lead the model to understand this two type of data. They label, for example, discover pattern using classification. If label are categorical or categorized, regression if label are numerical, for detection, determine whether examples are in the line with previously seen patterns. So here we guide from the previous seen data set that we use. Unsupervised learning, the data does not come with labels. So here the machine learning should understand the type and clustering of data. Here, the machine learning should understand the clustering of data. Usually, the unsupervised learning is much difficult when we programming or modeling than supervised learning. Also, we can build our customized algorithm for optimizing. So let's see who is data engineering or what's data engineering. Data engineering is the third pillar of data science. It has a few major areas: data management, prediction, software engineering. So data management is the storing, moving, and handling of data, include database management, pipeline, construction, data collection. Production, taking code that work well in prototype and make it really ready for operational, like automation, system integration. So here, protection, software engineering to ensure maintainability, scaling, collaborative development. We have data mechanism. The idea that there is some task we needed, like pre-processing for this data, which are really need what we call it, need heavy work, like data formatting. We need some time to, okay, we have the data, but we need to convert it as a string or as text or as number. We need to format this data. So it will give me much better result. Value interpretation, handling data and time in an interpretable and constant way. Response correctly to missing value. So I need to respond correctly if I have missing value at my data set, what I should do. We need to see the measurement unit correctly. Is convenience with this data set or no? So here we do like pre-processing for the data we have, data handling, like a query, slice the data. So here, like subset of the data that we needed. All this pre-processing is like existing work, extra existing work on the data scientist, for the data scientist, especially when we have a huge number of data. That's why it's like hidden task we have. Let's see if I am a beginner. Well, okay, we have the stages of data scientist, which is data science analysis, data modeling, data engineering, data mechanism. For the beginner, okay, we have here the explorers, professionally, and mastery. For the beginner, they understand the concepts of all these four stages. For the generalist, the general data scientist, they become professionally in the four model, but still they are general. For Diva, they are become more professionally in data analysis, data modeling, data engineering, but not on data mechanism. This is the difference between the person who we call it generalist and diva. The beginner, they are beginner, just understand the concepts and still beginner. Generalists, no, they become more professional by time and experts, but they know the whole four stages. For diva, they are expert in three stages. For detective, they are more expert in data analysis, and they are become mastery in data analysis and more in data mechanism. For Oracle, they are become more in data modeling, how we build the model, the algorithm, why this algorithm, not this algorithm, new algorithm combined between two algorithms or two techniques. So here they are become more mastery, more expert in data modeling. Okay, they know the whole, but they become more mastery in data modeling. For maker, they are more in data engineering. Let's see, they are know the concepts, but they are more experts in data engineering. For unicorn, they are expert and become mastery in the whole four stages. But the idea here, it's take long time from us to become more unicorn. So here he upgraded himself to become mastery in the whole four stages. But the idea here is take much time, expert um, in this field, years and years working to become on this position. So here the generalist profession at everything, the detective, a master of analysis, oracle, master of modeling, maker, master of engineering. So we have analysis, engineering, modeling, and the people who are expert in every field. The idea here, the unicorn person or the expert data science unicorn or unicorn data science, it's not easy to find people on this experts. So what should we do? Because by time, there are a few people who are unicorn data science. So here we need to replace this unicorn data scientist with the team. So data science team, which are specialist data engineering, data architecture, data modeling, to build this team because we have shortage in unicorn data scientists. So we need to build a team. This team, data science team, can be various roles like data engineering, data analysis, business intelligence, research scientist, decision scientist, and of course, data scientist. So let's see ideal scenario that we have data architect, data team manager, we have two to three data engineering to support the development. We have two to three data analysts to data scientists to analyze complex modeling. This is the ideal scenario. But in the real and the company, it should be Superman. We don't have the whole team. No. So for us, we need to learn how to use the whole data tools, which is the Superman, because many company thinking, okay, I will hire a whole this team and will cost me money. So can I have one or two from this team and they can do the whole working? This is what happened in the reality in the company. we should, this Superman should understand the whole data toolbox, explain the whole work that they do, learn how to write code, how to understand business needs, learn how to make model works like Superman. This is from the real side. So here we need to think like a data scientist in 12 steps. You can relate it to this article. We have the summary here. Data science process: set goal, explore, wrangle data, assess, plan, analyze, engineering, optimize, execute, deliver, revise, and wrap up. So here we have three stages, which is pre-prepare, then we go for build, then we finish and deploy it. So we have three phases with the 12 tasks. Prepare, we have set goals, explore, wrangle data, and assess. For build, we have 5. For finish, we have 3. Pre-preparation, the process of data science to become with that he have it with pre-preparation. So need to establish what you know, what you have, what you can get, where you are, and where you would to be. So we need to know our purpose and our goals and what we have. This is the pre-preparation. Before we start anything, we need to understand this. We need also to define what resource we have and to understand the purpose and the goal. So the first step to setting our goal. The goal of the project come from the stakeholders, the customer, that they need this, the expectation here. And then this will lead us to have the good question. So this lead us to have the correct information. Good question are concentrate on their assumption, what mean their assumption here related to the stakeholders or the customer that they need this project. Each goal should be put through parameters. We have like filter. So we have a good question, related data, insight analysis. We have useful answer. The idea here, imagine that we have the good question, but irrelevant data. So here the answer will be difficult to have it. So we need what is possible, what is valuable, what is sufficient of the data that we needed. This is the filter that we should filter the data we have. So applying this filter for our goals will give me the best goal for this project. So the idea here to have the real truth and useful answer from this data. So here we should apply scientific model. This scientific method, we should apply the scientific method, which is ask the question, state a hypothesis about the answer of the question, make testable prediction, test the prediction via experiment, draw the conclusion through the analysis of experiments result. The second step, exploring data, we need, according to our goals, to explore which data we should have and what we should collect. So here we have common format of data, like flat file, Excel file, Word file, relational database, non-relational database. We have struct data, unstruct data. So we need to understand what type of data we have or we should collect. So here we need to understand we have different type of format of data. We will use it. And also we need to understand what's its the data format that we will use it. After that, we'll go to wrangling data or data munging, the process of taking data and information in difficult, unstructured, or otherwise labораtive format and converting it to something that conventional software can use. The idea that when we collect the data, we collect it in format, but when we need to deal with this data, we need to convert it to another formatting. So here we need specific tools or algorithm to do this because we cannot do it uh, uh, file by file or data by data. We need algorithm to manage this. So here, what's the difference between data cleaning and data wrangling? Data cleaning process of detect and remove corrupted or inaccurate recorded. Data cleaning is another name of the for data cleanings. In data wrangling, the process of transforming and mapping data from one raw data to another. So it's become more variable. As example, okay, I have the birth year. Okay, someone birth in 2007, but we don't have the age. I know the year that he born, but I don't have the age. The age is more valuable for me than the year. So here I can convert this type of data. Assisting data to get to know the data better and to avoid problem with outlier bases in the data. What I mean by outliers is like, okay, that let's say I have data set for the people who are studying at university. So I have the born year and I have the age. If I saw that this student born on 2007, that means now his age should be or 2000, let's say 2000. So the age 25. But on the age field, it's 0. It's like outliers. How he's studying at university and his age 0. There's something wrong. Or his age 200. There is something outliers here on my data set. I need to manage this data. So here we have two ways, the descriptive statics and infrastatics. Descriptive statics is display of quantities of the data. Think descriptive like max, average, summarize of data. Sometimes we fill the missing data using the average or the mini or the max according to how we do the pre-processing. So in infrastatics, we have the quantities or knowledge of which you don't have direct measuring of this data. We don't have a statistical way to measure this data. So descriptive give me what do I have. Statics give me what can I conclude, which is much difficult to extract this information. Then we go for phase 2, which is building. You learn some, in phase 1, we learn how to pre-process this data. So we will go for building, which is step 5, developing plan. Plan and goals can change any moment. giving a new information or a new constraints that affect the building. So here, the idea that sometimes the customer or the stakeholder keep changing, or during our collecting data or writing our goals, or we find that there is extra goal we can have. The point here, we cannot just follow. We need to focus on what the customer or the stakeholders care about. Even that, we will waste time just follow what rules or what new we have. So after step 6, we go for analysis data. We can use statistical modeling, or we can use machine learning and black box method. Why black box? Because some time we cannot give justification why this happened in the machine learning, why we got this result, not this result. That's why they say black box. So here we need to choose the correct model that we needed. Engineering product, we have wide range of software is available for data scientists, from spreadsheet to middle statistical tool. So we need to know what is the correct that we can have it. You can build software using MATLAB, Java, Python, R. We have different kind of tools. So what is the correct one, or why Python not MATLAB? Why R not Python? So here we need to understand this software environment that we will use. Then we will go for optimizing data. Know some of the most popular and most benefit software for making your life and work data science more easy, like database using SQL or maybe non-SQL. We need to know what mean by supercomputer, computer clustering, GPU. GPU is like a hardware device can be fasting the processing. Computer clustering. We need during our processing a high speed computer, supercomputer? Do we need a huge number of GPU, CPU? We need to understand the cloud services. We need to know big data technologies, what data already we can use. As example, one of my student, he was doing his he is trying to training his model, but his PC is not faster. He cannot handle the huge number of data, so he go for Google Colab, which is online as example. It's much faster than his PC. So here we need to understand what what hardware we need. Executing plan. A data science project involve statistics expectation are based either on nation statistical or practical and usables. Practical usefuls. The idea is, okay, we plan correctly, everything correctly, but when we apply or execute this plan, we didn't apply it correctly. So it's not matter how good the plan is, it's always a chance that it should be revised as the project progress. So project plan can unflood in a number of ways, maintaining and awareness of outcome as the occur can be risk and problem. So we need here to usually trace the process we have. We need to be awareness what software we will use, what algorithm we will use, and we need to trace. Also, sometimes we need to modify our plan to follow what new we have. So good project results are good because they are useful in some way, and the statistical significance might be a part of this. So business does not care about your cool machine learning model. They care only about revenue, profit, and lose. So here, when I say I build a logistics regression model which predict customer loan with accuracy 89, or I say I build a model and reduce company lose $2.5 million. So this is the correct because they, as the data that we have, it should maximum revenue or reduce losing or wasting money. This is the hidden task for the data scientists to reduce losing money to increase or maximum the profit or revenue. After that, we'll go for finishing, which is delivery the product. So data science must understand the customer perspectives, and data science needs to choose the best media for a project and for customers, choose what information and result to include the product. So here we have to deliver the product for the customer, and we should have the correct way. We have two ways, passive and active. Passive product mean that customer only have like report, only the report the result. For active production, he have the application that the customer can use it and interact with. So here we give him like services only results like report. Here we give him the product itself so he can use it. After that, we need to make revision, like evaluate and feedback what we have. So with this revision, because sometimes we have misusing, we have error, we need to fix the problem, the error that we have it during the deployment. We need to have we need to have feedback. So here, not every problem need to be fixed. Wrapping up the project. Organizing project material and storing them in a reliable place can spare you from headache later. So here we need to wrap all the project on a documents like documentation. So in the future, if we need to do any improvement on this product or this application, it's easy when we go return to the documentation. In every project, we have lesson to be learned. So we need to understand what we learn from managing and implement this project. Usually we have some unexpected might happen. So we need to understand and evaluate what happened. So we have a help page within a web application. We need to have documentation. We need to write the documentation for every step we have. We have two type of uh, documentation: developer and code documentation. The code documentation describe all the method, the function, the inheritance, the objective we have from the code side. Developer from like the API is like the whole code, the architecture, the input, the output. So we have two level of documentation. So what skills to make data scientist he need? Communication, how to write presentation, email, how to communicate with the people, how to extract the information from them. Brief. That means some data scientists are afraid to move between roles. So we need brief for them to provide a huge benefit. For example, doing data analyst while keeping the limitation of modeling in mind. That means we should understand the whole process. So during our collecting data, we need to understand that from the technical side, we have limitation. I cannot promise the stakeholder that, oh, I will do 1, 2, 3, 4, but on another side, I have technical limitation or sometimes limitation in the budget. So here, the data scientist should know exactly what his area have, or from the side, especially from the side technical, should be understanding the whole process exactly. Or we will have a blind spot, and this will make trouble after that. Also, we need to know that we should be open and able to learn new tools, skills, and domains. Because as a data scientist, your job to work in different domains, so you should be able and open to understand. Success pattern: learn through practice. Some people learn through practice, but it's sometimes cost money and time. Monitoring, cross monitoring, community contribution. Share your work with others so you can exchange the experts that you know and they have. Education option: a career as data scientist. Degree: you can have like bachelor degree, master degree, PhD degree, certificates. You can go for some guideline course, a learning course. Boot camps: you can also join boot camps that help you to understand what is data scientist. Here, some few universities that organize and give training certificates for this major. Program can you follow and join? Free training, can you find it? So no need to pay, you can have this free courses. So here at the end, to develop a real world experience in data science is by work through a lot of small projects to get more experience. So finding data set you are interested. Okay, some people will say, oh, okay, I'm a junior, so no company want to hire me. Okay, I can by myself put the problem, collect the data and solve it, then I publish my results. So the people start knowing me. We have many platforms that you can publish your own job. So here we need to find data set, ask and try to answer question, write up result, raise and repeat to develop real world experience. Data science portfolio, you need 4 components to put in your CV: candidate, skills, real world experience, contribution in data science. So you need add this all to your profiles. This is some data science projects you can have. And thank you for listening. And goodbye.